Dear all, thank you for joining us today. My name is Osman Serhat Karaman. I'm the manager at digitalSSM Archive and Resource Space, Sakıp Sabancı Museum. I'm here serving as representative for the research project entitled Technological Arts Preservation, enacted through the collaboration of Sabancı University. Special thanks to Jeffrey Shaw, Morgan Strickos, and Matthew Laming, Tom and Son, Jack McConchy, and Cemal Yılmaz accepting our invitation. In this program, we aim to investigate the technical and non-technical challenges of preserving immersive media. And I want to give some information about the flow. We'll start the program with Professor Jeffrey Shaw's keynote, and then Tom Anson and Jack McConchy will make a presentation about Tate's Preserving Immersive Media project. And then we will have a break, 10 minutes. After that, we will move forward to the roundtable and Q&A session. Sorry. Please do not hesitate to share your questions and comments with us during the event. And now we can start. Jeffrey Shaw is a new media artist. Sorry again. Shaw was one of the first artists to engage with participatory, interactive, and computer-controlled forms of media art. He is regarded as one of the leading exponents of computer art. In this keynote, Shaw will share his views on preservation of his work of art, virtual sculpture, his pioneering augmented reality installation. And the initial version of virtual sculpture no longer exists. The ZKM has agreed with Jeffrey Shaw to acquire the artwork as an archive and create a media archaeological reconstruction for research purposes. At this point, I want to give the floor to Jeffrey Shaw. And dear Shaw, thank you again for accepting our invitation. We get honored with your presence. Please.
Okay, thanks a lot, Osman. Now let me see if I can launch share screen successfully. Okay, it should be up there. I'll just move this down here. Okay, again, thank you. I'm really honored to have been invited to this event to give the keynote. And I hope that in sharing my experience as a media artist, sometimes engaged in maintaining my own artworks, that this will be of value to others. So there are different strategies that one can take to approach this problem of conservation of media art. One, of course, is to simply maintain, or not so simply, maintain the original. And this means maintaining and conserving the original hardware and software. And of course, one problem is access to old knowledge. For example, dealing with software that's written in an obsolete language. Another problem is access to replacement parts. For example, failed components that are no longer being manufactured. Now, I have to admit that as an independent artist, the logistical and financial overhead of this approach, which is truly a Sisyphean undertaking, is beyond me. I would leave it to museums and institutions that have conservation departments with workshops and skilled hardware and software engineers to take on this challenging task. I myself prioritize the look and feel of a media artwork rather than the technologies underlying it. So I would tend to proselytize for another path of conservation. and that would be to migrate the original. And this means moving an artwork's look and feel into a more current hardware and software environment. This could entail a partial or complete recoding of the original. It could entail a partial or complete rebuild of the original. What we're aiming for is that the artistic result should, to all intents and purposes, look like and behave like the original. And this should be done periodically to evade obsolescence, I would say probably every 10 years. Migration of the original is best done in consultation with or under the direction of the author. If the author is deceased, it means referencing the actual work and all the existing documentation relating to it. And if the work no longer exists, then one can only reference what documentation there is. Therefore, it's advisable, actually essential, to assemble as much documentation and instructions from the author while he or she is still alive. That should always be part of the sale package of a media artwork. And it's also the responsibility of a maker if they intend their works to have longevity. Improvements may be cautiously done by the conservator to add robustness to the artwork, as long as it does not impact the integrity of the original. If possible, the author should be consulted and give approval for this. If changes have been made that alter the work in any way, I believe the public should be informed thereof. If it's considered to be meaningful and possible, relevant evidence of the original should also be presented concurrently. A typical example would be a 16mm film projection artwork that has been transferred to video projection. Another example is my installation Points of View, which was originally projected with a monochrome CRT projector in 1983. This was an extremely unreliable machine, and already that year I had to replace it with the next generation of 3-tube projector. Now, this meant projecting a monochrome image with a color projector, and the result is subtly different. And the artwork is different again today because now I'm using a DLP or LCD projector. The version you see here was a fundamental remake that I made in Vienna in 1999. Most of its underlying hardware and software were migrated to new platforms, though its appearance and functionality are almost identical to the original. And when I say almost, I mean sufficiently from my point of view as the author. The 16-track sound system that was originally provided by 8 car stereo auto-reverse tape cassette decks and a set of voltage-controlled amplifiers. Today, all the soundtracks are stored digitally in the computer and are modulated directly by its software. Now, while these cassette decks were part of the aesthetic presentation of its original, today I am satisfied just showing a photograph of it for the record, to document how it was done back in the 80s, because it couldn't have been done otherwise. As far as the sound experience goes, the migration to digital is close enough to exactly the same. The interface that interactively mixes these 16 soundtracks originally contained a cluster of optical sensors, but now its two potentiometers speak directly to the computer, controlling both the 3D sound space and the 3D visual space. Note that these soundtracks are mostly spoken texts, individually being spoken to the viewer depending on their point of view. I find it interesting that while the software for the original took many months to develop, the coding of the migrated version took just a few weeks because of the more modern hardware and software architecture. And it's far more robust and reliable. Back then, I remember being worried whether it would work or not every time I switched it on. Third strategy is the revision of the original. In the process of migration, modifications can be done by the author at her or his discretion, which may lead to artistic revisions and/or redefinitions of the work itself. A case in point is My Golden Calf. In its original 1995 version, it used a TV screen to show a virtual golden calf on top of a real pedestal. Its 220 remake uses an iPad, and 4 video cameras have now been integrated into the pedestal to enable reflections of the viewers to be seen on the golden calf's skin. Also evident is the much increased realism of the golden calf due to the increased capability of computer graphics technology today. So there are now 2 versions of this artwork, the one created in 1995 and the one created last year. They are the same, but very meaningfully different. And given its conceptual argument, it is a work that I might continue to revision to reflect changing times and technology. So in this talk, I want to focus on 2 case studies. The first is Memory Theatre VR, which was made by Agnes Hegedüs and her associates in 1997. It was commissioned by ZKM Karlsruhe for its permanent collection and is in the process of being migrated to new hardware and software platforms. When examining the original configuration of Memory Theatre VR, we see a number of obsolete components, including the Silicon Graphics computer and its IRIX operating system. So the core challenge is to port the entire application to a current computing architecture and operating system. Simply said, this is what we have to do to migrate a media artwork of this kind. We have to emulate or adapt the old code to a new computing environment, or we have to rewrite the code for the new computing environment, or just those parts that can't be inherited from the old. We have to extract and recycle all the assets, models, textures, photographs, videos, etc. Or we have to remake all those assets, or just those parts that can't be extracted. Our aim is to make an adapted new application that reproduces the exact appearance, and behavior of the original artwork. Now, in this process of migration, are we making improvements to the original work? Obviously, there will be hidden improvements due to the fact that the new hardware will be more robust and maintenance-friendly, as should the application software. But there may also be further qualitative improvements that are visible and experienceable. This would likely include better video frame rates, probably 60 to 120 frames per second instead of 30 or less. Also better rendering quality of all the assets of the models, textures, photographs, and the videos. Now, there are two options as a result of this that should be decided by the author. One option is to artificially reduce the performance of the new system to mimic the old. And the other is to accept and even welcome the better performance. The big advantage for this project of migration is that the original Memory Theatre VR is still operational. It can be seen, interacted with, and experienced. This becomes the reference for everything that is done in its remaking. So migrating this artwork to a newer platform involves a number of steps. First, we need to evaluate the application software and see whether it can be ported or emulated in its current form on a new hardware platform. If not, the application software will have to be recoded. The software engineer then needs to figure out how much of the original code can still be recycled or whether it has to be rewritten entirely. When rewriting the code, the engineer needs to try and interpret the old code, if that is possible, or simply watch the behavior of that code in the artwork, or a mix of both. Besides the application software, there are all the audiovisual assets used in the artwork's application. In the case of Memory Theatre VR, this involves 3D models, textures for those models, photographs, videos, etc. All these assets should be able to be extracted from the original application and reapplied in the new application. This is a very important part of the migration process, because if these assets cannot be recycled for whatever reason, they have to be built or sourced anew, and this can be quite laborious. Regarding hardware, the question arises whether we should still use the original Polhemus tracking system in the user interface, or are there better alternatives now, such as the InterSense tracker? Also, do we need to respect the characteristics of the original CRT projection system, or was it merely generic and therefore replaceable with, say, a laser DLP projector? There are other interesting contingent considerations that come into play when migrating this artwork to a new platform. Here are a couple of examples. Is the owner of this work, the ZKM, interested in considering that a new implementation of this work might also make it easier to travel to other locations, either as is or in reproduction? Because if yes, this could well influence certain decisions in the process. Is the owner of the work and or the author interested in creating a virtual version of the work that could be shared as an app? If yes, this could well influence certain decisions in the remaking process, especially if it's done concurrently by the same team. Memory Theatre VR offers interesting challenges in this respect because it is site-specific. It is a pioneering mixed reality work where the real and virtual worlds are deeply correlated on many levels. The virtual architecture, the acrylic model architecture, and its surrounding wooden architecture are like Russian dolls that furthermore integrate the actual architecture of the ZKM environment. So one needs to analyze with the author what steps could and would need to be taken if this work was to be placed in other contexts, such as another exhibition space, or become an app. So in conclusion, because the original artwork is still fully operational, and assuming we can access all its original assets, such as models, photos, and videos, then migration to a modern hardware and software platform is well within reach of a conservation team with the necessary skills, which the ZKM has. On the other hand, the only stumbling block would be having to remake the assets, the visual elements that Agnes Hegedüs created to constitute its virtual worlds. This would lead to additional effort, and one which may not fully succeed in reproducing the original. Now, the second case study I'd like to talk about is virtual sculptures. It was made by the Event Structure Research Group, that is myself and Theo Botzschreiber, in 1981. The software application was done by Larry Abel, and it was originally shown at the Melkweg, the Milky Way in Amsterdam. Virtual sculptures was an augmented reality artwork long before the term AR became currency. Its famous precedent, and certainly an inspiration for this work, was Ivan Sutherland's Sword of Damocles from 1966, while he was at MIT. It was only ever shown once at the Melkweg in Amsterdam. And actually it didn't even have a name back then. So it would be more true to say that this work is untitled. Its basic configuration was a CRT monitor over which was placed a Fresnel lens and a see-through mirror at 45 degrees. The monitor was mounted on a tripod in a harness so it could rotate and tilt. The artwork software application ran on an Apple II computer. Now, Apple II computers in those days provided paddles with which one could play games. These predated the mouse. They were simple potentiometers with rotatable knobs. But when attached to the harness and tripod of this artwork's construction, they could measure angles of tilt and rotation. The mirror above the monitor provided the Pepper's Ghost effect of seeing the monitor image floating out in front of you. The Fresnel lens lying on the monitor screen changed the focal length of the monitor image so that it seemed further away and bigger. The software that we used for this artwork was one of the first ever commercially available game engines. It was developed by Bruce Artwick for the original Flight Simulator, which became one of the most successful games of all time after Microsoft took it over. But Bruce also did something else quite remarkable. He sold the game engine itself, called A23D, so that other people could develop their own applications, which we did for virtual sculptures. Virtual sculptures is of course prescient in that so many artworks today are being developed with the current game engines, such as Unity and Unreal Engine. Now, it's important to understand the conditions under which this work was made. It was created by two artists who had very few financial resources. It was built just for one occasion, the event at the Milky Way. It was very much improvised. The tripod came from a flea market. The CRT monitor was second-hand. The only luxury which we were using for all of our projects at that time was the Apple II computer that cost about $1,500 at that time, which is equivalent to about $6,000 today. The construction of this work was completely improvised with materials that we had lying around in our workshop, plus a bit of custom metal work and a custom manufactured see-through mirror. This artwork was certainly never built to last, and it didn't beyond its one showing at the Milky Way. And many years later, I started a conversation with Peter Weibel concerning the donation of some of my works to the ZKM. We were both especially interested in older pioneering but now lost artworks and the possibility of rebuilding them. And virtual sculptures was an obvious choice. It was also a perfect challenge for the ZKM's Media Art Restoration Department, as it posed all the challenges of resurrecting an obsolete media artwork from the early days of computing. We decided to go two ways with this project. To do strategy 1 simultaneously, which is maintain, and strategy 2, migrate. I chose to rewrite this software completely on a current mini PC using a current popular game engine, Unity. ZKM, on the other hand, would source an Apple II computer and get the original application software running again. I can assure you ZKM took on a much more arduous task, which is still a work in progress. As far as the reconstruction of the entire machine, I took that upon myself in Hong Kong, working together with a brilliant electromechanical engineer and artist in his own right, Joseph Chan. Joseph was to remake the original work so that it looked and behaved almost exactly as the original one did. But this time to build it with high-quality materials and design it in such a way that it can go into the ZKM museum environment and be handled by thousands of visitors for many years to come, with the minimum of maintenance. While Joseph focused on designing an engineering solution, I sourced a tripod from the Ukraine on eBay, similar to the original, but much more difficult was finding an industrial 12-inch monochrome CRT monitor. I wanted to buy at least 3 so that there would be 2 spares. These have become very rare, and some that I bought turned out to be faulty. Luckily, ZKM has the in-house capability to repair these devices. Because I set out to recode the entire application, I could use a mini PC that was integrated into the actual harness. This had the really big advantage of keeping all the signal cabling within the enclosure. The only cable to the outside was 220 for power. And concerning the superior performance of its PC, I made sure that it emulated the Apple II, both in terms of its low resolution graphics and its slow frame rate. Now, I wanted to keep a memento of the original Apple II computer, so I bought 2 original paddles, which were integrated into the new design. But then I discovered that the potentiometers inside these devices were very noisy. So finally, I had to retrofit upgraded potentiometers. So all that's left of the original Apple II configuration are just the 2 plastic shells of its paddles. With a bit of trial and error, it finally came together very well. It is a paradigmatic example of what it means to conserve and technically improve a lost media artwork via a complete rebuild. And because I, the author, am doing this, I know which elements are essential to maintain the look and feel of the original. At the same time, I can authorize changes that make the work significantly more robust, user-friendly, maintenance-friendly, and hopefully capable to take the wear and tear of many years of museum life. It's also a model of what needs to be done, say, 10 years down the road, when it will need another hardware and software overhaul. One of the virtual objects that one can discover in this work is the aeroplane that appeared in Flight Simulator, whose game engine we used for the first iteration. Now embedded in a new game engine, it pays homage to its primogenitor and to Duchamp, of course. There is another aspect of this work that is certainly lost. It is, in retrospect, a site-specific work when having been shown at the Melkweg in Amsterdam, a unique environment that Wikipedia describes as a meeting place for hippies at the time. With magic mushrooms painted over its walls, our projected augmented reality objects came into a delicate conversation with the hallucinogenic zeitgeist of the times. When I premiered the newly migrated work at my recent retrospective exhibition at Osage in Hong Kong, Amsterdam's Milky Way could not be a reproducible surround for it. That world and those times have gone. So I looked for an alternative, and one which was not just the bland white walls of the Osage gallery space. I decided to work with the photographer John Choi and asked him to take a 360-degree panorama of Central District in Hong Kong, but without any people. Using Photoshop, I also removed all the brand names from the buildings in this photo. But if you look carefully, you will see many evidences of the political disturbances that rocked Hong Kong last year. This empty scene, with its aura of a sci-fi dystopia, converged during its exhibition at Osage with the onset of the COVID pandemic, which then actually did begin to empty the streets of people, and where the economic impact did lead to many big brands leaving their premises. So now the virtual objects of another time inhabit this new landscape like ghosts from the past, a sole surviving digital presence. A sole surviving digital presence that is now asking about the future of this present. So like the golden calf that I showed you earlier, the migration of this historical work turned out to be the opportunity for creating a new meaning for it relevant to the present. It's now Virtual Sculptures 1983/220. A question will come up, of course, when this enters the ZKM collection. What is its socio-visual context going to be there? Could it be a relocation of its Hong Kong iteration? Actually, I think it would be most appropriate just to locate it in the ZKM environment itself, given the ZKM's own history and identity. The digital ghosts of the past will certainly feel at home there. I'd like to thank you again for this opportunity, this wonderful opportunity to contribute to this event. Thank you.
Thank you so much, dear Jeffrey Shaw. And this is very wonderful presentation. And we will, in this roundtable session, the debate will revolve around the works referred to in the Jeffrey Shaw's keynote. And thank you so much again. And now we will move on with Tom Anson and Jack McConaughey's presentation. They are time-based media conservator at Tate, and they started a project entitled Preserving Immersive Media, in 2018, and this is ongoing projects. And this research project developing strategies for the preservation of artworks which utilize immersive media, such as virtual, augmented, and mixed reality. Dear Tom and Cenk, you can start. Thank you so much.
Thank you, Osman. I'm just going to share my screen. How is that? Can everybody see that okay?
Perfect.
Oh, thank you. Thank you, Osman, of course, for inviting us. And thank you, yeah, so much to Jeffrey for that keynote there. And I think, yeah, it's such an incredible insight into the kind of avenues available to us, and touches on, you know, it's just such a fantastic illustration of these such broad questions that we're faced with as institutions. So it was really helpful, and I can't wait to discuss more about it. Yeah, so as Osman said, we have an ongoing project at Tate looking at how we might preserve. This is more focused on the current generation of VR artworks, or that's certainly the avenue that caused us to start looking at this. So we'll give you a brief outline of our project, the timeline, the progress, the outputs, and areas that we've identified for potential development. So we had started, this initially started because we wanted to understand how we might use VR capture tools to document actual physical installations, and the need to stabilize some of that media that we were generating led us to do some preliminary research. We then worked with the London Art School, Central St. Martin's, on stabilizing a work that they had acquired by one of their students. And it was really then that we started to really understand how much artists, young artists especially, or artists of all generations, but especially at Central St. Martin's, were making with this media, how much work was being created and how precarious it is. Lumen Art Projects kindly supported the project, and they put us in contact with some artists and makers, and each of them we interviewed about their practice and their technical workflow. So we kind of looked at how we might use existing strategies of time-based media conservation, such as migration and emulation, and look at how these might be applied to these more complex works. And this was building on work that had been done within Tate and in other institutions on looking at complex software-based artwork preservation, which included real-time 3D works, which of course shares a lot of the complexities in what we're discussing here. So whilst our work has mostly been in the area of sort of contemporary tethered headsets, we recognize the broad range of technologies that we're working with here, including 360 video, mixed realities, phone apps, and we're of course interested to learn more and collaborate in those areas. And Jeffrey Shaw's examples there on these works, which are of course immersive and offer virtual realities, of such great examples of the breadth of works that we're dealing with here. But we have loosely used the term immersive media to loosely group these. So the main strands of the project have been artist and maker engagement. So we conducted interviews and explored the ways in which artistic intent meets the technology, the problems with stability that artists and makers might be encountering and ways that they might be approaching these problems, and how they could imagine their works being shown or interpreted in the future. We have been involved in community building through workshops and hackathons and with an amazing array of collaborators. And we've also worked on engaging industry, such as we went to the SIGGRAPH computer graphics conference in the US, and where we forwarded the interest of memory institutions against this backdrop of a conference of unbelievable scale that kind of celebrates rapid commercial innovation. And we were able to make connections with the teams developing open standards. So recognizing that we had something that looked a lot like a community, we developed the Ping email group so that anybody could share, use that email address and share relevant information. One of the project outputs has been an information gathering template intended to be helpful prompts during a collecting or stabilizing process, devised to be completed in collaboration with an artist. At an early stage, really serving as a prompt for all of these important questions. We explored and developed this template through working with the artists, and we also expanded on it through our workshops and our hackathons. It's been used and revised by Savannah Campbell and Mark Heller, and those documents and their revisions are available on our groups.io page, and we would encourage anybody to use that document and please expand on it. We have been working for some time now on a white paper, largely finished, although the pandemic set us back a little bit, so that will be published very soon. And I guess the idea was to provide a technical overview of the current generation of VR technologies, identify preservation risks, and try and come up with some tentative recommendations for how to proceed. In many ways, it feels like quite a sort of snapshot of a particular period in time. And we recognize this, and we've always been curious about how a more dynamic model of output, such as a wiki that has maybe a more, encourages more multiple authorship, might work to work with this kind of rapidly expanding area of technology that we're dealing with. So in the next slides, we'll very briefly outline some of the subjects in our paper. So this diagram shows the user alongside the main components of the computer hardware, illustrating the input and output points and situating the user as a part of this system. And if we take the headset for an example, it not only shows the outputs from the graphics output from the lenses, but it's also functioning as an input device, receiving movement from the input from the user's head. And this is useful to start to understand how much the user, as part of this system, that their movement or performance is informing the behavior of the artwork, and potentially starts to provide some points at which we can capture data that might start to gain a rudimentary technical document of the user's experience. So just zooming in a little bit on the computer system, the XR application here is key to preservation, the bespoke software and associated data. This application communicates with the VR hardware via what is known as a VR runtime, which is a software component usually provided by the manufacturer of the VR hardware used, which incorporates various APIs and drivers. So the world of VR runtimes is very fragmented, driven by commercial innovation. The support must be built into an application for a particular set of hardware. But the OpenXR group have developed an open standard for VR runtimes, and an adoption of this would mean that VR applications would only need to speak one standardized language. And if widely adopted, which it certainly looks like it is being at the moment, this would make using a variety of hardware much easier. And if that was combined with good legacy support, offers some potential to mitigate the effects of rapid hardware obsolescence. And I'm going to pass over to Tom for the next slides.
Thanks, Jack. So yeah, now we're going to focus in on the software itself a little bit more and talk about how that is produced. So among all the artists we spoke to during our research, a common method of producing VR software was employed. And this was the creation of assets which are brought together in a third-party game engine to create the software. So the assets are the things which fill the virtual environment, 3D models, the textures mapped over their surface to create materials. And assets have their own whole set of tools and workflows for production, and they're usually brought into a game engine fully formed. And the engine itself is essentially a pre-built software package for real-time 3D rendering, and it can implement a huge array of features. So things like lighting, physics, sound spatialization, scripting, and all of this can be extended with plugins and custom code. Unity and Unreal Engine, which Jeffrey both mentioned earlier, are the two ubiquitous game engines at the moment for this kind of work. And both of these have built-in support for VR development. Both were being used by the artists we spoke to. Next slide, please, Jack. So working with an engine today usually looks something like this. This is the Unreal Engine 4 editor. So you get the kind of visual interface which allows you to manipulate the scene through this central viewport. Your assets can be ported, arranged and lit, cameras and scripting added to create dynamic scenes and interactive elements. And then finally, from this software, you can build and package your software in an executable form. Next slide, please. So the VR software that you get out of an engine like Unreal is a mixture of compiled code and packaged data assets. And this will have a whole host of dependencies when it comes to running it. So it'll be built for a specific processor type and operating system combination. It will be built to support certain VR runtimes, which Jack mentioned already, which handle the communication between the host system and the VR hardware. It will have support for specific graphics APIs, which handle the communication between the host system and the GPU. And then, of course, there's a dependency on a GPU, graphics processing unit, or graphics card, and driver combination, which actually does all the rendering calculations required to achieve the relatively high frame rates that are desirable for VR to avoid side effects like motion sickness. And as you might imagine, the VR runtime here is particularly significant for VR applications, and this has quite a few important functions within running the process of running VR software. One of which is to correct the image sent to HMD, to a headset, to correct it for the distortion introduced by the thick lenses that are used inside these headsets to achieve a wide field of view and close viewing range. And that lens distortion correction will be specific to the lens within that headset. Next slide, please. So then this software is ultimately realized as a physical manifestation of the artwork. And these physical realizations can often be quite complex and interact with physical space and context in interesting ways. And it was interesting to hear Jeffrey talk about that in relation to both of the artworks he described. And the examples we have here on the left, there is a view of Lawrence Leck's PlayStation. This is a site-specific installation at the Whitechapel building in 2017. And this work responded to the building it was exhibited in. And the VR experience itself is actually set within the same building and models it within that world. On the right, you can see a view of a work by Jakob Steenson called Reanimated. It's just a small view of the installation. And for this one, the PCs and HMDs were actually mounted on these metal structures, and the PCs themselves clearly visible within the installation, which was quite important to Jakob. And then these bark chips were placed underfoot to evoke the forest environment that's experienced inside VR. So in both these cases, then, there's this very intentional relationship between what's experienced in VR and the characteristics of the physical space they're encountered within. Next slide, please. So after our work to kind of better understand these technologies, which is what we've briefly summarized in the past few slides, we wanted to look at what steps we could take now if a VR artwork were acquired. So we kind of wanted to come up with a set of pragmatic recommendations for anyone trying to collect or care for VR artworks now. So I'll briefly summarize that over the next couple of slides. So we'd start by ensuring we have a suitable computer and VR hardware set, which would usually be generating according to the artist's specifications. Install, configure, and test the software on this computer. Again, ideally working with the artist here. And as we would for other software-based artworks, and for the Tate collection, we'd want to keep at least 2 sets of hardware running for as long as possible. I think one other interesting thing to note here is that we would recommend disabling networking on these devices. And this came from a number of comments made by artists we spoke to who had to resort to keeping their systems offline to avoid the aggressive automatic updates that happen to the VR runtime software, which would frequently break compatibility with their software. Next slide, please. So with the hardware set up, we would then want to create disk images of the internal storage devices of the computer systems. And these are bit-for-bit copies of everything on that storage medium that we can then archive as a way of capturing the entire software environment stored on that disk. And this can be very useful for potential future treatments like emulation. The next step would be to gather and archive all the software components. So, of course, the artist created binaries, the actual executable software, any software dependencies required by that, and gathering those software dependencies is easier said than done because many of these are distributed through installers, which download material from the web behind the scenes. So they're not particularly transparent. And then finally, production materials. And production materials here could be quite complex. So we'd typically be dealing with an engine project file and any plugins that they had used. But we'd also need an appropriate version of the engine binaries so that we could actually open these project files. And further to that, because we're typically dealing with these third-party engines like Unity and Unreal, it raises the question of whether we would want the source code for these as well. And that's not necessarily straightforward. The Unreal Engine does have free and semi-public source code access. It requires you to link your Epic Games account with your GitHub account, but you can access source code, and the license is actually relatively permissive in terms of what we would need for preservation purposes. Unity, on the other hand, doesn't have full public source code. So there we would require some negotiation with Unity to arrive at an individual agreement, which obviously raises many questions about how practical this would be for a museum and whether what Unity would require back in return. So another thing we can do now is begin to document the artwork. Documentation isn't something that we explored extensively during this project so far, and Jack will come back to this topic later in some of the questions we have. But just to mention a few useful resources, there's the template which Jack mentioned earlier, which is designed to help with information gathering, the early stages of an acquisition. And there are also some very recently published workflows and templates on the Tate website, which have come as a result of another research project at Tate on preserving software-based art. So I've put the URL there. There's a few things that may be useful, like templates for recording information about disk imaging and emulation. And there's actually a guide to disk imaging that we've published as well. Okay, next slide, please. So that was a brief overview of what we identified as the relatively pragmatic steps we could take now, although you could already see that within that many questions are arising about how practical this would be. But for the last part of our presentation, we're going to consider how we might move into the future and the questions still to be answered, of which there are many. So as for other software-based artworks, one of our primary concerns for the longevity of VR artworks is the eventual failure and obsolescence of hardware. We realize that the stresses of gallery use are likely to accelerate this. And we've also noted just how rapid the speed of technological change is for VR hardware. So we're seeing hardware become obsolete within 3 years of release. And this means that replacing hardware like for like is unlikely to be possible for very long. Repair may be an option, but the industrially manufactured nature of the commercial VR hardware that artists tend to use at the moment may make this very challenging at best. So we may actually be able to run some VR applications on newer hardware for a while, potentially, particularly if open standards like OpenXR and Vulkan are adopted and used by artists, or can be applied during the process of acquisition. But with probable CPU architecture and operating system changes in the future, we have bigger problems to worry about. So we really need to think about other options. Next slide, please. So one option we have is to make changes to the software itself to keep it running in new environments. And one approach to this we've identified is to carry out regular incremental updates as new versions of the engine and plugins are released. This raises quite a few questions, though. There are multiple engine versions released every year, which would quickly make this quite significant maintenance activity for an artist or museum. And this really diverges as well from existing modes of conservation, which typically involve less frequent intervention. We're also aware that this is a stopgap measure. There's the likelihood of engine features being altered or removed, which may completely break the software. And the eventuality that at some point an engine will become obsolete entirely and stop being supported. So if we wait longer before intervening, we might instead be looking at migrating to another platform altogether. And there are some precedents for this in the video game industry, although these tend to be big projects with money behind them and not necessarily indicating this is the kind of work that would be feasible for artists or even museums like Tate. And if you add in the factor of not potentially having full source code access, in the case of perhaps the Unity-based artwork, because so much of the engine code is locked behind access restrictions, it starts to flag kind of potential problems with this approach. And we're also concerned that within this process of potentially migrating to a different engine or rewriting in a different language, what will be lost in that process and what kind of characteristics of the work could change. And it's interesting to hear Jeffrey's insights on that and then the kind of idea of what's an acceptable level of change. So there are really lots of questions here, and I think the two case studies that we're discussing today could be really important examples in helping increase our understanding of this. Next slide, please. So emulation is another option we could look at, which uses an emulation layer to simulate obsolete hardware in software. And this is obviously a well-known and widely used way of playing old video games on modern hardware, and increasingly used in conservation and digital preservation. And while this is quite appealing in comparison to migration, as it's far less resource intensive, there are quite a few limitations that we've identified to applying this in the near future. I think probably the most significant of these is that we still need to connect to physical hardware, connect to a head-mounted display or tracking system, which can be a problem for emulators. And we also have quite limited support for real-time 3D rendering in emulators at the moment. And both of these may change with distance in time and growing computer power. So while emulation is very useful right now, it could solve some of our problems in the future. So with that, I'm going to pass back to Jack for the last couple of slides.
Thanks. Yeah, and this is just thinking ahead to documentation as preservation. I think this this kind of relates to a point that Jeffrey was making about in the absence of actually something that is working, the importance of as much documentation gathering as possible. So, yeah, what can we capture of them? We could render 360 video, and this is a practice currently employed by collecting institutions. This obviously has pros and cons. It removes the dependency on the real-time 3D rendering, and so is easier to preserve, but also crucially, you've lost that interactivity and is only a single perspective of the original open-ended experience. Within the gallery context, there is uses for this as well as documentation. It could function as some kind of viewing copy potentially for curatorial departments or researchers. But of course, it shouldn't be mistaken for having experienced the work. And technical documentation is only really gathering one dimension of these works. And I think we're starting to think about how we might capture something of the embodied experience of these artworks. One thing we have access to already are tools for capturing what is seen through a headset. And this can be combined with cameras of how people are behaving in physical space. So a point of view capture could be complemented by an external capture. And there's precedent for this from gamers using tools to publish their gameplay online. We have tools that can capture sensor data to give us an idea of some data about how people were actually moving. And when we consider, I think, that people who are experiencing these artworks in a museum context, they're really experiencing convergence of the artwork and the technology and that intersection. And it points to a very interesting set of questions about that, how that convergence will change and how we can understand that over time. And into that mix, I think both Jeffrey and Tom have talked about the physical space in this and how the artwork might actually be exploring that intersection of the virtual and the physical and vice versa. So looking ahead to our continued research, our friends and project partners Jesse de Vos and Raza Boyste at Netherlands Institute for Sound and Vision have secured some project funding to support research and development. So we're currently in a process of outreach to gather feedback on things that we might be able to develop that would help the community. That might be the developments of tools that would enable data or graphics capture or calibration, or perhaps the funding of a case study that would on which we could explore strategy. And we're still very much inviting input into that process. So please, if you have any ideas, do get in touch. Our white paper, as I said, will be coming out soon. And we have set our research questions for this year, our kind of research priorities. And these are very much probing at understanding that relationship between artwork, technology, and experience, and how that will change over time. We'll start to look at what documentation we might be able to gather and how this can be interpreted and reinterpreted into the future. We want to continue to work with memory institutions in collectively monitoring the evolutions of technologies and strategies. And we're always looking to expand our working group of interested parties, bringing together museum people, makers, and industry people in the hope of tackling some of these issues. So if you'd like to be involved, then we'd love to hear from you. I think there's always this the simmering idea of a glossary. I think we found during hackathons that we actually lacked some of the terms that we needed, the common language that we needed to be able to describe some of these artifacts that we were experiencing. And so we started a community-sourced glossary of terms. And so there could be some interesting developments there. But if your interests intersect with ours in any way, then please do get in touch. Yeah, and just to again say thank you so much to Osman and everyone for inviting us, and to Jeffrey to give us those insights into those artworks. So yeah, I can't wait to hear more. Thank you.
Dear Jack and dear Tom, thank you for your presentation and inform us about your fantastic projects. Now we have a break, and we will back 10 minutes later. See you soon. Hello again. We will move on with roundtable session, and in this session we will argue that Jeffrey Shaw's virtual sculptures and Agnes Hegedüs's memory theater VR. And before the discussion, I want to give the floor to Morgan and Matthew. They are digital and media arts conservators from ZKM. And dear Morgan or Matthew, please.
I start just to introduce what you're going to say, Matthew. So yeah, like Jeffrey said in his presentation, both of those artworks, virtual sculpture and memory theater, are into our collection. And so we are the ones who are doing this restoration work. So for virtual sculpture, we are doing this media archaeological reconstruction with an Apple II and the original coding. And like Jeffrey said, it's a really complicated process. Matthew will explain better than me. And for memory theater, we choose to do the option 2. So we decided to extract all the assets from the original software environment. And Matthew will explain which kinds of difficulties we had to extract 3D assets from SGI. It was soft image, I think, soft image 3D software. And so, yeah, I let just Matthew explain you the different process we went through for those 2 artworks. And like this, we can discuss with all the knowledge about those 2 case studies. Matthew, it's you.
Thank you. So I will start first with memory theater because we are currently working on this one. So actually, I'm working right now with Dr. David Link, who's actually in charge of the migration from the old version to the new version. And he has actually talked with us about the difficulties of having all those old 3D models working on a new environment. Because on the SGI was made with software called Soft Image 3D. And this software existed until 2015. It has been bought by Autodesk recently, which is doing 3ds Max and Maya, other popular 3D softwares. And they decided to discontinue this one to integrate into their own respective softwares. So the first thing was actually to try to extract those 3D models, and we wanted to have the last soft image version from 2015. But since Autodesk discontinued the project, we had that famous commercial problem. We couldn't buy it anymore. It was not possible to have a license anywhere. There was just a demo version, which was very, very limited. So I had to pull up a pirate version to be able to try that. And actually it was not working either because the version was too recent and it wasn't able to recognize the old memory theater scene format. So we've done that for nothing. And but then I managed to find an old version. We found an old version. It was actually on archive.org of Soft Image 4, which was the version used back in the day. And this one actually worked. So David made an old computer on Windows XP, installed the software and loaded the files, and it worked. So he was able to export them into the OPJ format, which are the most common and open source format. So it's very practical for conversion and long-term preservation. Then he started to write an OpenGL engine by himself, but he had problems by importing the OBJ files into that because they had polygon problems due to the object themselves. So since it's not his domain particularly, and I happen to have a lot of 3D skills because I'm interested in that. So he asked if I can have a look to try a solution to correct those problems into the objects files. And I used one of the software that I'm using privately for my hobbies to try that. Let me share the screen. Yes, it should work now. So for example, in this scene, that's actually the reconstruction of the original versions, but you can see this little pig model. And when I first opened it, it was like that. So you had like missing polygons that you can see here, also here. And his OpenGL engine actually wasn't able to have the complex polygon working. So the polygons that has more than 4 points. So I used for every object of the artwork, I managed to select directly all the defective polygons, to triangulate them, to re-export them. And we found out that actually when I've opened those in my software, I also had the texture information that was embedded in that. So it was really good because now that all of the objects are now triangulated correctly and are working into the new version, David had a problem with the texturing of the objects because he was still missing the information for the image files to be which position on the object and etc. So that's now my new task to help him on that, and I still have to do that. So yes, and so that's, yeah, you can see the difference in the original version. There's the images, and we have all the references since the artwork is still working, which is very, very good for us. And for now, it's like looking like that. So all of the objects are working correctly, and now I have to apply images on them. Yes. And now for virtual sculpture, that's another task, because it's not a migration that we are doing, as Jeffrey explained before. We are actually rebuilding and reconstructing the original version. So first, the thing we had to do was to acquire an Apple II, which is kind of difficult today to have a fully working one. So we went to our best friend website, eBay, and we found out it was an Apple II Plus, so not the original one. It's just one with more memory. And we bought it, but it wasn't working actually, this one. It was starting, but no display, nothing. But fortunately, this one was coming with all the manuals. And at this time, Apple was providing with all of the schematics for the motherboard and documentation. So it was really good for me, because actually the Apple II came out before I was born, so I'm really not familiar with that. And it's very, very different technology than today's iMacs, for example. So we found another Apple II on eBay, we bought it, and actually this one was not working too. But I managed to identify both problems on both Apple II, and they were different. So I was able to actually read all the documentation, schematics, and after 2 days of headache, I understood how it was working, what was not working, and I managed to pull out and exchange the damaged chips on one and take from the other one, the working ones, to have a fully working Apple II. So, and now actually the new problem is to have the 3D software working, because Sublogic is an old software, was the first flight simulator a long time ago. And also thanks to Archive.org, we managed to find the original documentation and floppy that was uploaded by the founder, actually, Bruce Hartwig. He did it himself, so thank you. And it's quite complex, because unlike the 3D I'm doing for Memory Theater, for example, or the 3D I'm doing just for myself, by the time you had no interface, no software that you can just like draw the thing, like redraw the plane, for example, or just the tube. It was made in assembly language. So you had to understand and do a bit of mathematics first, and you had to code directly the 3D, which is very, very different. So that's the part I'm in. Actually, I have the full documentation. I think I read it like 4th time already, and I need some more. But that's where we are right now.
And we need time to continue. Are people who knows how to code in assembly language really fast? And I'm sure, Sema, that there are people at the university who knows.
Yeah, that would be better. Yeah, because that's back from my school days, the assembly language. So I need to dust that off. So if we can have someone who fully go on that, that would be really helpful.
Yeah, I'm afraid I don't, at least in computer science departments, I'm afraid, it is difficult to find people who know assembly, right? Maybe in EE, like electrical engineering departments, they may know, but in computer science, I don't think anybody knows. But one thing that I want to say is that, it's like a lot of effort, right, for you to, write this assembly and everything. And one thing that you may want to do is that since this is related to like a game engine, and since those game engines are used by multiple art projects or multiple games at the time, right, you may want to spend a little bit more time to make your effort more reusable, in the sense that, you can come up your own programming language, right, which can automatically generate, then you can write a simple compiler and automatically generate those assembly language, like a high-level programming language specific for that game engine, right? Then that high-level programming language can be used by other people in other restoration projects, right? So, what I want to say is that it is a lot of effort, right, doing this. Just a little bit more effort, you can make this effort reusable, and this could be good for the community, I believe. So I was thinking that,
Yes, that's true. I was also thinking, actually, and since Jeffrey told that actually the plane was from the one from Flight Simulator, it's still a popular game, and I think there's also players with nostalgia. I know I have like old games from my childhood that has been ported to new operating system, and maybe this one I didn't started to search yet, and I was thinking perhaps someone ported the old Flight Simulator, how it was done perhaps, and that can use that technique for virtual sculpture. Actually, I was thinking about that also. Maybe someone already made that compiler.
Yeah. And I think it is important for the, I believe, well, I'm coming from a different world, so I believe it is important for the art community also, to share like that knowledge in the form of libraries or in the form of tools,
Of course.
Yes, that's
always our plan. Yeah.
Yeah. I was about to say that's what we do actually. Each time we develop a technique that can help for artwork, we share that.
I just wanted to add that when we start the talk with Jeffrey about virtual sculpture, it was really like, you were telling me, if you want to do this, you can, but I don't want to be involved. It's too complicated. And I think you were not like seeing the purpose of this. of doing it with the old language. And I think it's because we are a museum and we want to share not only artworks, and we want to preserve not only artworks, but also knowledge. And I don't know if you remember, but I think it was in 2015, the NASA, they asked for people who knows Fortran and assembly language for maintaining the Voyager 1 and 2.
Voyager, yeah.
So, you know, the need is there everywhere. And if we can have this, like some of this knowledge preserved also at ZKM, thanks to virtual sculpture, I think it's important as a museum's like mission. But of course, for Jeffrey, the goal was to be able to show the artwork in its full functionality and robustness, because of course the Apple II version won't be exhibited in the room and for public. It will be just for research for us.
Morgan, if I may say, there are two thoughts that come to mind. One is Larry Abel. He did it. He built it. And last time I knew of him, he was somewhere in California and may still be.
I tried. Yeah, I contacted his company and they told me he is retired. And they forwarded my email to his private email, but he never came back to me. So.
He didn't reply. Oh, but then you must give it to me and I'll have a go at it, because he did something else at that time, which is also, I have to just, I'll just add a little anecdote to which you're probably not aware of. So at that time when we built that work, I have to tell you, I was completely computer illiterate, totally, okay? I had just no idea how to do anything. But at the same time, I didn't want to have a situation where the images which we were using in this work, that I couldn't build them myself, right? And so actually, believe it or not, Larry spent about a year building a high-level tool for me using one of the first-generation tablets, so I could actually build these models myself, right? And
it's so great to have this.
And actually, there are three versions of points of view, each more complex than the other. That where I was able to actually build these virtual worlds with that very elegant tool that he gave me, which had nothing to do with coding at all. It was really just a it was soft image version, you know, sort of the progenitor of what became, you know, the kind of toolkits that one would need to build 3D objects.
So exactly what Semal is talking about.
You had the tool back in the day.
It is like capturing your knowledge in the form of a high-level tool that can be used by anybody.
Yeah.
So that, you know, that makes sense. Okay. Oh, by the way, let me introduce myself because I didn't have a chance to do so. So I'm Cemal Yılmaz. I'm a professor of computer science. My research interest is software engineering, especially software quality assurance. So what I do is that, you know, in particular, I'm working on software testing, software security, and, dynamic data-driven program analysis. And I've been working in this project with Osman like for a couple of years now. And in this project, my interest lies on the software aspect of preserving digital art. So, you know, so there you go. I introduced myself. Okay. Whew. Yeah, I work at Sabancı University, by the way.
Maybe we can start to talk about the question Osman wants us to talk about. I let you, Osman, introduce the thematic.
Okay. I tried to contribute to this session. This is different from technical challenges. And first, my question is to Jeffrey Shaw, firstly, and maybe we can talk about it. I think last September, I did an interview with Memo Aktan. He's a computational artist, engineer, and computer scientist. And he thinks of all new media installations as more of performances. Performances that last years and keep going. After that, only the documentation remains. And of course, documentation could never evoke the same feelings as the work itself. However, that is also the advantage of documentation, because documentation does not attempt to evoke the same feeling as the work, and the viewers do not expect such a thing. It just attempts to give information. On the other hand, even 5-10 years later, when the work is presented in the same technical ways as the original, the viewer's expectations is to feel the work exactly as it was. And Memo Aktan think that 5 or 10 years later, that is not even possible. And these type of artworks have an impact today. Even if something is to be conserved, what is more important to me is the history of the works, or their impact at the time they were made, how they direct the discourse, and if necessary, their position on the trajectory when seen 10 years or 100 years. And my question is, I will say, can the impact of an artwork be conserved, considering it has been technically conserved just as it was? And I asked this question to you about the virtual sculptures. I saw that not change only the technology, change installations, maybe change the impact of artworks that visitors will have visitors what they think about it. What do you think about it? What do you want to say about it?
Look, it's a fantastic question, and it's. I mean, just simply this. The question: can the impact be conserved? I mean, can the impact of any artwork be conserved? You know, can the impact of a Picasso be conserved as it was seen in its day? On the one hand, I think, you know, I can just give one example where I know where an impact factor is lost and absolutely cannot be conserved because context has changed so much. And again, and going back to the golden calf, the first generation of the golden calf predated the tablet, predated the iPad. At that time, nobody took a screen in their hands. Screens were fixed to a table or fixed to a wall. Screens were not something you took in your hands. Suddenly there is an artwork that invites you and actually has a little text on the side which says, you know, hold me here, to sort of make it clear to people that I want them to pick up the monitor because this is an unusual thing to do. So suddenly, for the first time, people are holding a screen in their hands. And also, they are moving the screen around and discovering that this screen is a window into a virtual world. This was such a fresh and unusual experience at that time. And of course, now it's ubiquitous because tablets are everywhere. Everybody knows, handling a screen is a totally ubiquitous experience. So that impact factor of that moment, and not so long ago, 1995, is lost. Yeah. So in a way, the new version of Golden Calf is an attempt to bring back impact, to bring back an impact factor that belongs to the present, yeah, so that the work will not just be a historical artifact in the present, but will also have, will be given some new, let's say, given an impact which is relevant to the media. Now, this is not something that necessarily needs to be done in the conservation of a work. It's something that's possible.
Actually, we can't do something like this without the artists.
Yeah.
Like the Golden Calf.
Yeah, I know. But it is a crucial question, and actually, as an artist, I never see myself making work for the future. I only see myself making work for today. I'm always surprised when a work has some energy which takes it through to 1 year or 2 years ahead. It surprises me because actually the work was really created to address a very, very current circumstance. It talks to the present. And when I see a work like The Legible City, which has had a survival of, 20 years now, 89 years, I'm surprised by this. I'm also gratified to know that something is there, let's say some impact factor that was built for created at a certain moment of time, somehow has longevity. Yeah. And actually, I start to think this is maybe the magic of art. Art is something which is able to transcend time in the sense that it may not be what it was, but it keeps somehow, it has the energy to regenerate itself and to contain meaning which becomes relevant to future generations. But where this comes from, I honestly don't know. And it's not my intention when I'm making a work that this should be the case.
Thank you so much, Jeffrey. Yeah, that's very important issue and very difficult for me.
So let me just add one thing. In the body of work which I have made, I have two experiences. One group of works which that are able to transcend this time span and maintain their longevity, and other works that really get lost in the past. So when you look at them, the only way to appreciate them is to understand what they were then, because as they are now, they are somehow sort of, in a way, emptied of interest.
Thank you. I want to turn to Morgan with same question, but I want to add some sentences. Yeah, we know that the historicity of artworks, and Morgan published a brilliant article in 2013, I think, titled Digital Art Preservation, Practical Answers to Theoretical Issues. And she has a question: historicity and long-term access and irreconcilable conflict. And what do you want to add with my question and your question to these subjects?
It was a question I asked in 2015, and I think I have an answer now after working at ZKM for so long. And I'm agree with everything Jeffrey said, but I'm not agree about the impact of old artworks. I'm pretty sure it still has an impact if we are doing the right didactic, explaining people what it is, where it comes from. And, with this type of artwork, like Jeffrey said, it's, the question of the impact is raising because we can change the medium of the artwork. This wasn't possible before, like the Picasso. And with digital art, we think we can. And actually, can we really do this? Like, we have the chance, of course, with media, to be able to make the artwork evolve with technology and makes maybe its concept or its impact on the public follow the different technological changes and be in kind of a way respectful to the initial wish or idea of the artist. And I think Golden Calf is really perfect for this because you really had in mind this kind of tablet. And so it's really like a precursor technology. You were thinking something like this, you did it, and it happened in the past. So it was complete vision, like the technology was saying what vision of future technology you had at that time. And I think it's really important to explain this to people when they come to a museum. And so, yeah, I think the question is here, like, should we be respectful to how the artist envisioned technology, or as a museum be respectful to explain the artists think at that moment with the technology available at that moment. And I think to preserve the impact, we should just explain it, being more didactic. But I think I have a good example of this is that Debbie Douglas from the MIT Museum told me one day about those artworks that were dated, like virtual sculpture, that it was making the same effect of than Pong, the video game, on current generation. Like her students, when they were playing with Pong, they were saying like, "That's it, it's lame," and without the didactic around Pong saying, it's really qualitative video game for that time. If we are not explaining that, they cannot appreciate the game. You know what I mean? Like, it's a Pong effect. If you're not explaining, or if you are updating, like without improvement, like, with virtual sculpture, you are letting those really dated graphics. For memory theater, we are not changing the graphics. And if you are doing this without the didactic, people are just thinking it's a bit simple, and they're gonna start to make comparison between artworks from the 90s and artworks from the 20s or 2020. And I think it's unfair for the new generation also. But yeah, I don't know if I was clear enough. I didn't speak English in so long. It's really hard today.
Thank you so much. Jake and Tom, do you want to add any your thoughts, if you want, on the subject?
Yeah, I think I feel like I've got quite a depressing response in a way, which is like that. Like, sometimes it feels like there's this temptation, and I have it myself, to be like, what is the answer to this or something? And all too often I find myself like, it takes me loads of work to get back to that point of being like, it depends, you know, and it kind of depends on the artwork, you know, and I've like been recently like had this kind of like, I think it's like a fairly established sort of way of thinking about artworks, but it's kind of new to me, and I think it's really helpful. And that is this kind of like question of like not what the artwork is, but like what does the artwork do? And that helps you, that gives you this kind of like tool to kind of like navigate through some of these questions, you know, because by asking what it does and what its functions is, you encounter the interactions that it's creating, or you encounter the effects or something that it's creating in people, you know. And maybe like the sort of golden cow example, you know, is like, what was the artwork doing? Well, it was like a vision of the future, and what was it doing? It did have an impact. It had this like technological shock. And so with the artist, you've then, by asking that question, what does it do? You've got this kind of like idea that you can work with or something, which is like, yeah, we could work with this idea of shock or something, you know, or impact or vision of future or something. And so it can sometimes be a bit helpful to kind of like, for conservators certainly, to try to work towards those themes of what the artwork, of what is important to maintain of that artwork through time, you know. And I really like the golden cow example as well, because I think that this is like something that we're encountering all the time, which is that like artworks being remade and then having relevance to different points in time. And then I think that for conservators, that asks the question of us, like, how do we, I think Jeffrey said something about, what did he say? That there was like a relevance of the new version. There was a new set of sort of parameters or something that was like important about the new version. It was like in a new way or something. And then for conservators, I think we have to kind of like, as we kind of maybe restage a work or something, think about like, what are those parameters that were important about that staging of that work at that particular time or something, and maybe that's helpful. And I also just wonder, this kind of, yeah, one example, the case study that we had at Tate, Lawrence Leck's PlayStation, in which he had created this world in a game engine, and he was like, my understanding of what he was saying was that he was saying, whatever tools you have available to give people to access this virtual world I created, go for it. You know, just like, this is a world at the moment, it's like a headset or whatever. But like, that's going to change. Just do whatever, you know, whatever you got, just access the world, you know. And maybe that's kind of in a way what we're talking about. Is like, how do we, you know, what's the world of the artwork or something? And one other thing I thought about is just, we're sort of talking about this like being like didactic, and then we're referencing artworks, historical artworks. And I wonder if progress, it sometimes feels to me like progress is a little bit exponential, and that maybe we're having to do that quicker for more recent artworks now than we used to. And I don't know if that's maybe just my feeling of like not being able to stay on top of things, but that actually feels like maybe like another challenge that we're facing with this particular type of technology-based artwork, is that it's everything we've encountered before, but everything feels faster and more complex or something. So yeah. Sorry if that's a depressing state of affairs.
I actually found this all quite uplifting, because, you know, Jack and I have been looking at these contemporary artworks, and we're just like, you know, our conclusion is often, how the hell are we gonna deal with this? Like, they're so fragile. But then to see that you both, you know, Jeffrey and the guys at ZKM, that you've been able to keep these works running, one of which is 40 years old, I think, this year. I mean, it's really incredible, and it shows what's possible. And kind of makes me wonder, you know, what will this same pattern play out in the future? Because I think what Jack was just saying was very interesting, because there's this increasing distance between, I think, artists and technology. So the difference between, you know, someone working with this crazy manual for the Silicon Graphics workstation software, and someone working with Unreal Engine today, which is basically like drag and drop. You know, you don't need to do any programming to make a VR application. Yeah, with that increasing distance, I mean, I guess the technology underneath is growing in complexity. Does it mean that the problems, you know, that we're talking about are going to be much worse 40 years from now with artworks that were produced today? Or will I don't know, will we have caught up in some way?
It will be worse because you see the distance with the software, but also with the hardware. Matthew was able to repair an Apple II just by understanding how the chip on the board was doing. And you said yourself, like the VR glasses, it's super difficult now to repair them yourself because it's super tiny. And so, yeah, Matthew, you.
No, but as I mentioned before, I have the example just here. I'm repairing an iMac. It's from 2011. It's already 10 years old. I don't have the documentation from Apple. I had for the Apple II, so I just had to read it, and it was easy. But for this one, fortunately, on the internet, you have people like me who are doing reverse engineering, and you can like find some kind of documentation. But that's not the straight documentation like back in the days, because also the mentality of the companies evolved. There's also this aspect, which is very frightening for me.
Yeah, I can also, I guess, comment on this. I think the issue here is that, the technical issue here is that the artwork depends on like a thick hardware and software stack over which the artwork has no control. That is to say that, that the hardware and software stack may change without letting the artwork know. And, and those changes need to be addressed in order to make sure that the artwork has a long lifespan, right? So therefore, from that perspective, we will always have that problem. We will always depend on some hardware and software stack, and then they will always keep on changing as the technology changes and everything. That thing will stay the same. However, well, compared to the past, probably we know what the issues are today, right? Probably we'll take care of them. We'll find ways of addressing them. Therefore, like documentation, like archiving things. Now we know the values of those things, and I think we'll do a better job in the future addressing those issues. So I have a mixed feeling. It may be better, but I feel like it may be better in the future because now we know what we are doing. Now we know what the issues are. Now we have pretty good experience with the technology, and it should get better. But it's just like gut feeling of mine.
We can learn from the past. I wanted to answer also Jeffrey's question about the graphics of memory theater, if we are going to improve them. Since we extract everything from the 3D environment, we have all those objects and we're going to code them in a new environment. And one of Jeffrey's question was, should we or can we update the graphics, and the different elements inside the environment?
Look, it's a really interesting question. Generally, I would say no. No, simply because I find the achievement of the original work to already be on a very high level. So the aesthetics of the original work are good. And the things which are in that world, they look like they look because they are intended to look that way. And so there's no really, there's no improvement that can be made in the from that point of view. I mean, the kinds of improvements you might look for, as I said earlier, is things like frame rate, yeah, because I always think that low frame rate, there's nothing aesthetically pleasing. I mean, I should hedge that by saying that in the old days, I found the jaggies very aesthetically pleasing, and certainly an aesthetic component of some of those early wireframe works were the fact that they had jaggies, because the jaggies actually automatically animated the lines. And without the jaggies, the lines would sort of become somehow boring, right? So the jaggies gave life to these very crude objects. So there you have something where I would say, no, don't improve that. Don't increase the resolution, because we'll lose the jaggies and we'll lose something that was important. But with Agnes's work, I really think what she has created is a very beautiful virtual world. That it's true, it's a virtual world that was built with the tools of its time. Maybe if she would build it today, she would do something else, but it was, I think it's a complete work. But there are some details, for instance, like there are some films which are being projected within the virtual world, some movies, right? And there you might say, okay, what is the resolution of those movies which are being projected? Maybe that's something that might look better if that can be improved. In other words, if we can have a texture, a movie texture, that's a higher resolution than was possible then. So these are like tweaks that don't in any way, but these are tweaks that don't change the core aesthetics of what has been created.
It's kind of the robustness that we were talking about with the tripod of virtual sculpture. We just had some robustness, and I think it will be the same with the films from Memory Theater, just adding some readability to the artwork.
I mean, there are certainly certain simplicities that were forced on us in the early days that are not detrimental to the long-term aesthetic appreciation of the work. Yeah. And again, something like Legible City, which are just flat-shaded letters in a very minimal landscape. Yeah. Nobody has ever asked me, or I've never felt the need to improve that 1989 world. Yeah, it reached a conclusion then, and that's where it is. Yeah.
I think it's because the public, when they come to ZKM or to any museum, they know that they can read, the labels and the date. And as soon as they know from which period of time it is, they pass this and they can just appreciate what was done at that time. And I think this is maybe...
Then they've become good art historians of media art.
Would the wall label there actually describe if it was a new version of that work? So if it had been updated?
We have both on the labels of ZKM. We have the original, what it was, and on what technology is running now. Mm-hmm. So people can satisfy curiosity when they when they can notice sometime it's been updated. So we just wanted to be transparent for this, like saying it directly. It's not running on a Laserdisc. It's a floppy. It's not a floppy.
But for the 3D artworks, that's something I always felt. You were talking, Jeffrey, about Legible City, like the flat shade environment. That's also part of the artwork, right? Mm-hmm. You don't want to change that to add like reflection or today to running on an RTX graphic cards, because it won't be the same. And I always made, when I as a visitor, not a restorator, when I'm looking at the artworks I don't know of, always had this parallel with the video games, because I also like video games, of course. That's you have like video games, like today you have like remakes of video games that they use the new engines, they do the the portings, and you're like, yeah, that's really nice. The graphics are really nice, but that's not the original.
Yeah, and I think it's interesting that there's this kind of resurgence at the moment in, an interest in 90s and early 2000s rendering technology in kind of indie video game development. So they're finding ways to recreate things like Jaggies and, low-res textures in modern technology.
Yeah. It's trending actually today to have the old. I played a video game recently that was using the old Quake 1 engine from the 90s. That now that it's software, they released the source code. So that's also hope for the future about Unreal Engine and everything. That's you have a 10 to 20 years delay, I will say. About like I have 20 years old games. That's the company that still exists, of course. They release the source code like, yeah, we don't care anymore, enjoy. And that's really nice for us. And they actually updated the Quake 1 engine to run on modern computer, but to still have the original rendering with the flickering polygons that was part of the engine. So stuff like that, yeah.
So have you ever thought about using AI to get the look and feel of, original look and feel of the artworks? Like, you bring the look and feel to somewhere close to the original look and feel, and you kick the AI engine in and say, okay, let's fine tune this look so that it gets closer to the original one. So I'm just, speculating here. Maybe, this could be something that can be done.
I use that for memory theater for the tracker, for reproducing the tracker, the picture. Actually, we did a scan of the original one, and actually to enhance the image, to have a bigger resolution for the printing and to clear, because there was like hole on it, and we don't want to have the holes are not on the exact same place on the new one. Wanted to correct that, and actually used AI to enhance the image and keeping the same image. So yeah, that's my personal example.
Yeah, I was talking about this. So I have the source, original look and feel. I'm reproducing that. I brought the look and feel to a point, and then I say, okay, go AI engine. What the AI engine in this particular case can do is that start perturbing the image, just to make it look similar to the original one. And it keeps on applying small perturbation until, a satisfactory similarity is obtained. Just speculation.
May I share a little anecdote in that context? In 66, 67, I made an animated film, 16mm animated film with hand drawings. They were it was just black and white, hand painted. Actually, it was done together with another artist, a Dutch artist, Chipper van Ten. We did little drawings alternately. And we created together I think in half a year or so, we made maybe, I don't know, some hundreds of little drawings. And then we used a 16mm camera to basically capture a few frames of each image. And then we ended up with an animated film, which we were quite proud of at that time. But then recently, one of the artists in the faculty at CityU is doing a lot of work with machine learning. And then I thought, well, we've got these hundreds of drawings. Can I give them to a computer, and can it learn, the rules of how these drawings were made? Can it get to understand them and start to generate its own, right? And indeed, it worked really quite well. We ended up with a program which was creating, you could say, it was indeed creating images which were absolutely within the language of those images we had created, but were new, really new. And also now suddenly we had a machine It didn't have any time limitations. I mean, you could just let it run. It was generating hundreds, it could be thousands of images. So we're suddenly in a new space altogether. And also the animation was interesting because originally, we were compelled to shoot it with a 16mm camera, which means we fixed the animation frame rate, and it was no longer variable. But now suddenly I have all these images which I can load into a computer, and I can give the viewer a slider, and they can go from 0 frames per second to, I think, something like, 120 frames per second. So they can basically steer the animation framework dynamically. So suddenly, again, we have a situation where a work which actually is still, I think, interesting as a historical artifact, but has been sort of transported into the present and actually is now engaged with machine learning as a way of giving it a whole new lifespan.
If we could just get the machines to learn the entire artist, then
well, of course, the famous example of the British artist Harold Cohn, who's dedicated so much of his life to actually trying to build a software architecture that would paint his paintings for him. And he did very well. I mean, he spent a lot of time refining that tool so that in the end it was making the paintings he wanted to make, and they were his paintings.
Yeah, it's a great example.
Yeah.
Thank you. Maybe we can pass to the Q&A session, and the time is running. First question for all. How do you think the specific characteristics of an experiment can be evaluated and documented as dependent on the technical specifications of virtual reality work? In other words, how do we look at 2021 work and document the characteristics that must be maintained in 2030, for example? From Luis. Do you want to answer this question? Anyone? No question. Okay.
Well,
No.
I mean, Tom, didn't you? I think you gave an answer earlier. Basically, the author can tell you. Yeah, and for instance, I think you gave the example. The author said, "Look, here's my virtual world. Any way you get into it is good enough. Doesn't matter, right?" And suddenly you have one answer to that question, and that is maintain the virtual world, but any way that you can get into it is a viable solution. So the artist is describing the parameters of how the work can of what needs to be kept, what needs to be maintained, and what is allowed to be let's say mutatable over time.
Okay.
Could also just reframe that slightly and ask you, Jeffrey, and Morgan and Matthew, what was the useful documentation for revisiting virtual sculpture and memory theatre VR? What did you have that was very important, and was there anything that was missing that would have helped?
We had nothing but Jeffrey. There were only those pictures we saw in Jeffrey's presentation and Jeffrey's memories. That's all. But we wrote a documentation, of course, about the artwork, but we had nothing. And this is really what's important right now, is that in our collection we are contacting all the artists and we are doing interviews and we are talking with them and we are asking them, like, should we update the graphics of memory theater, for example? So we are asking all those questions about the changes that can occur on the artworks in the future. And we are doing it now because, like Jeffrey said, there's a lot of update that cannot be done without the artist. We cannot sneak into the code like this and change a lot of things. Or like Golden Calf couldn't have been done by a conservator, like this iPad version. Or conservators are becoming artists and we decide that we can reinterpret all the artworks, which will be really fun, but it's not really the duty of a conservator, I think. But with digital art, we are going in that direction sometimes, like thinking if the artist had access to this technology. So yeah, it's right now it's artist-based documentation, I would say. We will see in the future if it was enough, but already there it's a lot. Yeah.
So I need to share another another anecdote with you, because it's there's a certain irony to the fact that we are now, at this point in time, taking conservation of these works so seriously, when I can assure you that that in the 60s and 70s, when we were making these works, in the 80s even, the notion of conservation was very, very far from our minds, and quite the opposite. We were enthralled by the idea that our works were ephemeral and would disappear. In fact, we felt insistent that we were creating work for the now, for the moment, that really had no destiny in the future, and that was not something we should think about. And actually, I remember as an art student, I was making peculiar sort of Rauschenberg-like collages, and I remember one professor came to me and said, "Listen, I can't take you seriously because this can't be conserved and it will fall apart in time." And I said, "Well, that's just the point, I'm making a work which can't be conserved and will fall apart in time." And we were also making prints which were with a certain medium that would fade away in sunlight, and that was the whole point, that you put the print out and then suddenly it would just, within a short time it was gone. So the ephemerality of things was very much tied to a sort of an embrace of immateriality, and certainly a reaction against, the physicality and the longevity, let's say, of the myths around art at that time. But in retrospect, of course, there is a little regret here. There are a few things which are very, very poorly documented. They're accidentally documented. We did an installation in Belgium at Knokke, and I wanted some film documentation. I found a filmmaker who had been there, and he sent me his film, but he spent all his time zooming back and forth, back and forth, back and forth. That's what he was doing. He was making he was not making a movie, a documentation. He was making his own artwork, and it was zoom in, zoom out, zoom in, zoom out. Had no real use to us. But so there is this kind of paradox. Maybe not now. I mean, maybe artists now are more engaged with the idea of the longevity of their work. But certainly at that time, I embraced the short-termness of it all.
And I noticed that there's an urge right now to preserve the artworks from the 70s, from the 80s. Like, we are making reconstruction of artworks like Colloquy of Mobile, from Pask, from Gordon Pask. We are doing those things. And I think there's something in our generation that is kind of nostalgic of this moment of experimentation that was in the from the 60s to the 80s, I would say. And maybe this urge to preserve this is just the urge to preserve this moment of experiment that was between artist and engineer, between like they were just doing experiments and not really taking care of conservation, kind of this spirit of just doing and we will see. And so maybe our generation wants to preserve this because they want to preserve this spirit. Maybe there's something like this. I don't know.
I also think it's like, I think that really just like sort of pokes at that feeling that that's what museums do, isn't it? That's like where the museum's interests like sort of like veer off into just the museum's interests, which is just to hold and like sort of like fix or something like that, you know, and just be like, oh no, don't change this, you know, we're like a memory institution, you know. And it's like, obviously there's like a huge amount of work that's being done in understanding how we can work with artworks that do change over time, but like we're deeply rooted in the idea of artworks that don't change, or like of fixing or something like that. And I think that what you were saying, Morgan, you were saying something, I think, about the kind of conservator as artist or something, or as the sort of like agency that you do have each time an artwork is displayed or something. I think this is like a very real thing, isn't it? That we all need to be a bit more transparent about our interests and our subjectivity and what we're bringing to each like instance of an artwork or something. That of course the museum has its interests, which is like to hold on to this like historical artifact or something, and the conservator is bringing all of their decision making based on their position at that time. And I think actually, like, certainly it feels important for the history of an artwork to be transparent about why we made those decisions. And almost that's like, you might very well make a decision which in the passing of time looks quite odd or something, like an odd decision at the time. But as long as you're transparent about the process that you went through and why you did it, then with the benefit of hindsight, you can look back and say, okay, well, that's why they made that decision, but we do it differently this time. And you haven't taken the artwork off in the wrong direction or something.
And with creating the Media Wiki in ZKM to document those kind of decisions, because it's easy, it's collaborative, and people can just write it down. Like, I did this because, and so I think for the historicity, we have tools now to do this documentation really well.
I agree that kind of like multiplicity of voices and sort of multiple authorship and sort of the instantaneousness of record keeping, I think is like quite helpful in this, I think. Yeah.
Thank you. We have no question from attendees now, and maybe Matthew or Morgan, do you want to ask any question to Cemal about technical challenges to face on virtual sculptures or memory theater or VR?
Actually, I already got an insight about the tool, the idea you had, so I was already some helpful idea for me because I wasn't thinking about that yet. Morgan, perhaps?
Yeah, it could be also a good idea to do some kind of cooperation on those kind of things. We should experiment. Actually, it's a time for experimentation, and we are open to experiment with you with all those kind of things and brings new brains from outside of the museum. Because sometimes we're stuck in a museum and we are just talking to museum people.
Right. So as a matter of fact, I believe maybe Osman mentioned that. So this semester I'm offering software verification and validation course, which is a double coded course. And one student is interested in doing a project. Like, this is a course, project-based course. Like 50% of the grade comes from the project. So in this field. And now with this, I was looking for a project, right, for her. And now I know what to do. Maybe I should share with you and get your get your idea. I think it was inspired from Tom's talk. So here's what I want to do. Let me know whether it's a good idea or not. This is going to be a tool, right? So let's assume that I have an artwork. I know the dependencies, like the technologies that artwork depends. And the Tom asked that, when should I maintain that that artwork, right? When should I really do and port it to new technology? So I was thinking of developing a tool which will every day query the repositories for the technologies that the artwork depends on, which will automatically build the artwork. I'm talking about the software aspect, and which will run some test cases, and which will warn the user that something has changed about the technology. Now, your test cases is failing. There may be something wrong with the artwork. You may want to maintain your artwork. How is that?
This is exactly what we wanted to do with our database. Target the artworks with Flash, for example, and the day Flash died, just pop up some warning somewhere saying in 1 week they won't be working anymore. And this is something we were thinking about, and I think it was maybe Dragan Espenschid from Rhizome who wanted to implement those kind of tools for his database too.
Yeah, that's very interesting, because Flash was very advertised. The ending, you had like pop-ups everywhere on every computers, but we have a lot of technology that actually died without anybody knowing it because it was like abandoned for years. So that's a very good idea. Yeah.
Okay.
Can I just say as well, I love the idea of that as well, and we're actually in the process of designing a new digital repository that, and we are making the not the dependencies visible outside, because that feels like it's something that we've always been really interested in, but we're certainly trying to make that data as accessible as possible, so that if a tool like this comes along, we're in the position to be able to utilize it. So yeah, it's really interesting.
Yeah. I'll then keep you guys updated. I just, thanks, Tom. It was your, I was thinking this tool, right, during your presentation. So I'll let you guys about the results. I can share the tool with you, if it is of high quality. We'll see.
Thank
you. That was great.
With pleasure.
Yeah.
Okay, so thank you, all of us. Time is out now. I'm very happy to being together with and thank you again for your contribution to our project. Thank you so much again. We have to finish.
Thank you, Osman. Thank you all.
Yeah, thank you all.
Thanks, everybody.
Thank you all.
Yeah.
Great.
Yeah, I hope we have another opportunity.
Yeah. In real life, hopefully.
Yeah.
Hopefully. That's right.
Or virtually. Ultra virtual.
Yeah, take care too. Bye-bye. Bye-bye. Morgan, we'll see each other, I hope.
Yeah.
Okay, bye-bye.